No, this is a perfect comparison, a lot like comparing pronghorn antelope to the true antelope, and those morphological similarities are due to convergent evolution and not because they shared a close common ancestor. Same thing is happening in the hyenas. So there are 4 species in the Hyenidae, the family that contains hyenas. We have the aardwolf, the brown hyena, the striped hyena, and the spotted hyena. So when we take this group and just plot it as the Hyenidae, right, the family, we get this phylogeny. So I know this phylogeny is too small to read on our little phone screens, so I'm going to enlarge it here in a second and kind of walk us through it. But I want to just orient you to what we're seeing here. So this whole phylogeny is the phylogeny depicting the evolutionary relationships of the carnivora. That is the order of mammals that contain the carnivores. And it's, as you can see, a really diverse group, right? From seals, etc., to the weasels, to all of the cats, the dogs, the hyenas, etc., etc. If it's a mammalian carnivore, it's in carnivora. So notice where the Hyenidae is on this phylogeny of carnivores. And you'll see that it's nested within the feliforms, the cat-like carnivorous mammals. And notice how far that is on this tree from the Canidae, the dog family. So what this tells us is that the similarity in morphology, like body shape, skull shape, teeth, between dogs and hyenas is the result of convergent evolution and not because they shared a common ancestor that had all those traits. So, in other words, hyenas and dogs resemble each other because there have been similar selective pressures in the environments in which they were evolving that favored the evolution of similar body types. So let's sum up. Hyenas and dogs look similar due to similar selective pressures driving convergent evolution in body type, skull, teeth, etc., not because they share a close, recent common ancestor. In fact, hyenas are much more closely related to cats than they are to dogs.